Hi there, it's Mr. Clark. Welcome to lesson 3.1.2 on compound intervals. So, in the previous lesson we looked at intervals going from a unison to an octave, but there can be intervals that are bigger than an octave, and we call these compound intervals. So you can figure out the interval size of a compound interval exactly the same way. So G is 1, A is 2, B is 3, C is 4, D is 5, E is 6, F is 7, G is 8. That's an octave. So I probably just could have skipped to octave and said G is 8. But then A is 9, B is 10, C is 11. So this is an 11th. You can reduce a compound interval to a simple interval. Simple interval is just unison to an octave by moving the top note down by octaves until it's you can't move it down anymore without going below the lower note. So in this case, you can move the C down an octave. Bam. Oh, and I know that that's a fourth just by looking at it. We want to get to the point where we can look at simple intervals and be like, oh, yeah, that's a fourth, or like, oh, yeah, that looks like a seventh, just by glancing at it. You don't have to count every time. That would just get to be a pain. Like, why would you want to do that when you could just be like, oh, that's a seventh. Great, move on with your life. Anyway, so even if it were like a C up there, you can move it down an octave, move it down an octave again. You can reduce it to a fourth. If you're not looking at written music and you just know, hey, I have an 11th, then you can just subtract 7 and you get to a fourth. And the reason you subtract 7 rather than 8, like you might think for an octave, is that same off by 1 thing I was talking about in the previous lesson, where the distance between a note and itself is 1, when the distance between like a point in itself in geometry is 0. So you have that off by 1 error, so that's why you subtract by 7 rather than 8. That is all I have on compound intervals. I will see you next time.